Hi students, welcome to Jayadev Academy. This is Raghava, chemistry faculty. So today we are going to knowing about the carbon and its compounds in this one chemistry lessons. So carbon and its compounds. Why? Because we have to discussing this topic because only it is the reduced syllabus in previous academic year. That's why this is a new academic year. Again we have to going to facing the new academic year. In that academic year definitely they will be including this lesson also. That's why we are discussing the first mostly important topic of the chemistry, that is the carbon and its compounds. It is not only the lesson, not only the topic, it is the one of the branch of the chemistry we have to see. So why? Because carbon, so it is an organic chemistry. Chemistry categorized into the 4 parts. In that one of the part is only occupied by the carbon. So that is the carbon and its compounds. Preliminary information, how to knowing about the element of carbon, and what are the different natures of the carbons, and why carbon is taking into this importance, and how to forming the structures of carbon, what are the forms available by the carbon, how to giving the name of the carbon compounds. These are all we have to discussing in this carbon and its compounds. Is it right? So now let us going to the lesson. So we have to seeing the first of all carbon. Is it right? So in that one, first of all carbon, it is having the 4 covalent bonds. First of all carbon, it having atomic number 6 and electronic configuration. So 1s2, 2s2, 2p2, 2p2. That means last p shell definitely it will be having the, we know as per electronic configuration p shell maximum electronic configuration is 6, but only 2 is filled in this one, only 2 is filled. So how to filling these total electrons, so how many electrons are vacant is there, that is the combining capacity of the carbon, combining capacity of the carbon. So how many electrons is required to fill the last shell? How many is there for 6? 2 plus how many is equal to the 6? That is the 4. So that's why that 4 electrons is taken into the its combining capacity, combining capacity. At the same time, based on the that only carbon can forms the 4 covalent bonds like 1, 2, 3, 4. Is it right? So it is the central carbon, it can be forming as an 4 covalent bonds, 4 covalent bonds. Is it right? So that we have to seeing the carbon can forms the 4 covalent bonds, and it is a valency is 4, and at the same time its atomic number 6, and it is related to the non-metallic 14th A group, 14th group or 4th A, 4th A. So 14th group or 4th A group, 4th A group, it will be related to the element. So these are all the non-metallic nature groups we have to taking. These two is there in the non-metallic nature. So metallic, it is not the metal, but always carbon is having the same metal characters. All characters it will be express the metal properties only. How like? So it is having the malleability, ductility and conductivity. It is not having the only sonorous property, only sonorous. Why? Because so we know coal, charcoal, and simply in our surroundings we have to seeing the cow dung also. సో వాట్ ఈస్ ద కౌ డంగ్? అసలు ఏంటి అసలు ఇంతకీ కౌ డంగ్? ఇట్లా మనకి కార్బను 4th ఏ గ్రూప్ ఎలిమెంటు, ఇందులోనూ కార్బను వ్యాలెన్సీ 4, ఇవి కంప్లీట్గా ఇట్లా పీ షెల్లో 6 ఎలక్ట్రాన్స్ కంప్లీట్ అవడానికి ఛాన్సెస్ ఉంటే ఓన్లీ 2 ఎలక్ట్రాన్సే ఉన్నాయి. అందుకని దీన్ని రిపీట్ చేసి కార్బన్కు ఉన్న కంబైనింగ్ కెపాసిటీ 4, రిక్వైర్డ్ ఎలక్ట్రానిక్స్ 4, రిక్వైర్డ్ ఎలక్ట్రాన్స్ 4A. సో అయితే ఏంటి ఈ ఫామ్స్లో కార్బన్ ఎందుకు డిఫరెంట్ ప్రాపర్టీస్లో ఎక్స్ప్లెయిన్ చేస్తుంది, ఎందుకు ఇంత ఇంపార్టెన్స్గా డిస్కస్ చేస్తున్నాం అంటే బికాస్ ఆఫ్ ది ఓన్లీ ద రీజన్ carbon is there in the everywhere in entire world will be become into the carbon. సో దట్ ఈస్ ద బెస్ట్ ఎగ్జాంపుల్ వీ హ్యావ్ టు సీ. అంటే మొత్తం ప్రపంచం అంతా కార్బనే ఉంటుంది, కార్బన్తో లింకప్ అయ్యే ఉంది. దాన్ని మనం ఎలా డిస్కస్ చేయగలం, ఎలా నోవింగ్ చేయగలం? బెస్ట్ ఎగ్జాంపుల్, మనం రిలీజ్ చేసేది కార్బన్ డైఆక్సైడ్, మనం తీసుకుంటుంది ఆక్సిజన్ O2, బట్ మనం రిటర్న్ చేసేది కార్బన్ డైఆక్సైడ్. అంటే అక్కడ కూడా కార్బన్ అనేది కనిపిస్తూ ఉంది మన బాడీలో కూడా, అవునా? సో అందుకని ఇక్కడ 4 రిక్వైర్డ్ ఎలక్ట్రాన్స్ ఉన్న కార్బను 4 కోవలెంట్ బాండ్స్ని ఫామ్ చేస్తుంది, 4 కోవలెంట్ బాండ్స్ని ఫామ్ చేస్తుంది. అయితే సో కార్బన్ డిఫరెంట్ ఫామ్స్లో ఉందంటున్నాం. ఎందుకు సోనారెస్ చూపించలేదంటే మన డైలీలో ఎగ్జాంపులే చూస్తున్నాం. ఏమేంటవి? సో కోలు, కోకు, కౌడంక్. కౌడంక్ అంటే ఆవు పేడ అంటాం మనం డైరెక్ట్గా. సో ఎండిపోయినవి అవి. వాటిని చూస్తే వాటిని కొడితే సౌండ్ వస్తుందా? రాదు. అట్లాగే కోల్ని కొడితే సౌండ్ వస్తుందా? బొగ్గు, కాలిపోయిన కర్ర కొడితే సౌండ్ వస్తుందా? రాదు. హ్యామర్తో హిట్ చేస్తే ఏమవుతుంది? డిస్ట్రాయ్ అయిపోతుంది ఉంటుంది, స్మాల్ పీసెస్గా విరిగిపోతుంది. సో దట్స్ సింపుల్. ద ఎవ్రీ కార్బన్ కాంపౌండ్ ఇట్ డజంట్ ఫార్మింగ్ ది sonorous property. So that's why it is going to the non-metallic list. So at the same time carbon it will be always forming the bond angles of 109 degrees. So 5 minutes here we are seeing the, so experimentally it will be identified the 109 degrees 28 minutes. 109 degrees 28 minutes. That means the bond angle in between the carbon to carbon 109 degrees 28 minutes. 28 minutes. So that is we have to seeing this is the bond angle and bond length. It is in the nanometers. That is centimeters we have to seeing the at the same time nanometers to 1.0.154 or 1.55. So 1.55 nanometers we have to seeing. So up to bond length will be expanding into the carbons. సో ఇందులో మెయిన్గా కార్బన్స్ ఎక్స్పాండేషన్లో ఎక్స్పాండ్ అవుతున్న కార్బన్స్ ఇవి, ఎక్స్పాండింగ్ కార్బన్ బాండ్స్ అనేవి ఇలా ఎక్స్పాండ్ అవుతూ ఉంటుంది. ఆ బాండ్ లెంత్ ఇలా ఉంటుంది, కార్బన్స్ ఎక్స్టెన్షన్. సో ఇట్ ఈస్ దెన్ trigonal bipyramidal shape. So how like see this? Trigonal bipyramidal. సో డైరెక్ట్గా పిరమిడల్ షేప్లోను ట్రైగోనల్ బైపిరమిడల్ షేప్లోను కార్బన్ కాంపౌండ్స్ అనేవి ఫామ్ చేస్తున్నాయి. దిస్ ఆర్ స్ట్రక్చర్ అండ్ అబౌట్ ది కార్బన్ ప్రిలిమినర్లీ. So but why we have to discussing the carbon? Carbon is having the some more important properties. Similarly they are having the versatile nature of the carbon. What is that versatile nature of the carbon? Carbon can available into the different forms. So that is 2 types of forms we have to carrying this total. What are that? So one is the directly crystalline form, another one is the amorphous form. Crystalline form and amorphous form. So crystalline amorphous forms we have to seeing briefly. Crystalline form diamond, graphite and Buckminster fullerene we have to seeing the crystalline forms. Is it right? So next one we have to seeing the another thing. So it is a carbon amorphous forms we are seeing the, so only the compound will be available in the that form of the coal, charcoal and cow dung. Is it right? So these are the amorphous forms of the carbons, and carbon will be there in the everywhere we have to seeing. That only carbon products we have to seeing the everything. Petrol is the carbon product, diesel also carbon product, cosmetics carbon products, cloth carbon linkage structure, our body also carbon linkage structure. But a totally biggest carbon compound in our body is the blood cell. It is nearly having the 3,22,000 carbon linked structure. So that is the blood cell linkages carbon structure we have to seeing. Is it right? So now how to these crystalline and amorphous forms, these we have to seeing. So after we really these carbon only, why? Because first one, versatile nature of the carbon, that means same element can available into the different forms, same chemical properties and different physical properties, having the different physical properties, same chemical properties and different physical properties, that compounds we have to calling as an so versatile natures of the carbon, that is we have to seeing crystalline, crystalline, crystalline and amorphous forms of the carbon. Is it right? Crystalline and amorphous forms of the carbon. And the next one we have to seeing the, so how to carbon taking into the these importance, because of the only the reason hybridization. So carbon only involving into the three types of hybridization, that is the sp, sp2 and sp3. So what is the first of all hybridization? Who introduced the hybridization? Means this hybridization, father of the hybridization, he is introduced the hybridization, Linus Pauling. Linus Pauling. So he is the one of the greatest chemistry scientist, and he introduced the hybridization. Hybridization means the intermixing of atomic orbitals to forms the new hybrid orbitals. The intermixing of atomic orbitals to forms the new hybrid orbitals. New hybrid orbitals. That we have to calling as an hybridization. That hybridization is introduced by the Linus Pauling. Linus Pauling, he is the one of the Nobel Prize get from the because of introduction of this hybridization, and he is started from the 1954 to 1962. Is it right? So next one, so sp and sp3 hybridization, how to this intermixing one s orbital and one p orbital, one s orbital and one p orbital combining to forms the sp hybridization, sp hybridization. And here one s orbital and two p orbitals, one s orbital and two p orbitals, so combining to forms the sp2 hybridization. And here one s orbital and three p orbitals combining to gives the sp3 hybridization, sp3 hybridization. So like this we have to seeing the combination. Here they will ask the off mark bit immediately based on the these content. So what is the valency of the carbon? What is the valency of the carbon? Carbon is related to which group of element? Is it right? And next, what is the versatile nature of carbon? How many forms of carbon is available? Two types of forms, that is the crystalline, amorphous. Crystalline and amorphous. So that is we have to seeing. And here amorphous forms of the carbons and crystalline forms we have to seeing, and carbon is only involving into the what are the hybridizations. So what is mean by hybridization, and how many types of hybridizations carbon is involving? That is simply we have to seeing the sp hybridization, sp2 hybridization, sp3 hybridization. In sp2 hybridization, how many s orbitals or how many p orbitals are involving? One s orbital and one p orbital. In sp2 hybridization, how many s orbital and how many p orbitals are involving? One s orbital and two p orbitals. So sp3 like that, 3 means 3 p orbitals and 1 s orbital, like that. Only p orbitals are there in the three types. So that is s, px, py PZ, that is the axis of three-dimensional rotation of dumbbell shapes, axis of three-dimensional rotation of the dumbbell shapes. So electrons are revolving in these dumbbells of Px x-axis rotation, Py y-axis rotation, Pz z-axis rotation. So like that they will be revolving in the axis of rotation, that's P only, Px, Py, Pz. Sp hybridization will be takes place either be Px or Py or Pz, any one of the p orbital. So that is combining to forms the sp hybridization. Sp2 also either be Px, Spx, Py, Pz. So either be it will be involving into the directly s orbital involving into the Px and at the same time Py, like that, or Pz, Py and Pz, like that they will be involving into the hybridization. So these are here we have to seeing the both three orbitals are involving into the hybridization, Px, Py, Pz, Px, Py and Pz. Three orbitals are involving into the hybridization. Is it right? So now here these type of questions they will ask the how many orbitals involving and what is the hybridization. What is the hybridization? Is it right? Who introduced the hybridization? Who introduced the hybridization? Very most important question. Who introduced the hybridization? That is the Linus Pauling. Is it right? Next one, see this. So intermixing of s orbital and p orbital, s orbital and p orbital, vacant here s orbital and the pz orbital, they are mixing to forms the new hybrid orbital, thus the sp hybridization, it is the linear structure, then it will be the angle is the 180, is it right? Sp hybridization. And here see that, so one s and two p orbitals, one s and two p orbitals. Here see, this is the s orbital, we have to seeing this is spherical structure, and one p orbital p, so another p orbital we have to see. So these are all mixed together to forms the new hybrid orbitals, that is the sp2 hybridization, Here the bond differences, angle differences in between the any two orbitals is 120 degrees, Simply we have to see this is the intermixing of atomic orbitals to forms the new hybrid orbital, that we have to taking as an hybridization. That hybridization is sp and sp2, is it right? So these hybridizations we have to see. And next one, sp3 hybridization, how to forming the sp3 hybridization. See here one s orbital, is it right? So three p orbitals, px, py, pz, and these are all intermixing to forms these four hybrid orbitals, of four covalent bonds, with the central atom of carbon, These formation, for this sp3 we have to seeing the example formation of methane CH4, sp3 hybridization, and here see that sp hybridization, that means C2H2, here we have to seeing, and for that C2H2 is the example for the sp hybridization, then C2H4 is the example for the sp2 hybridization, and Hybridization examples we have to seeing the C2H2, and sp2 hybridization we have to seeing the C2H4, and sp3 hybridization CH4. So like this, these atoms, only carbon is involving into the three types of hybridizations. That's why it is a very important role playing in the compounds and periodic classification of elements also. So in that elements also it will be the very highest useful and important role playing element. That's why we have to taking the carbon can be involving into the three types of hybridizations. It is the X, Px, Py and Pz. These three orbitals are intermixing and to forms the 4 hybrid. Like that only these 3 orbitals are intermixing, forming 3 new hybrid orbitals, Px and Py. Like that only we have to seeing the S and Px orbital. Directly they have to involving, overlapping to forms the new hybrid. Here we have to see previously it is a 180 degrees bond angle linear structure, and it is a 120 degrees bond angle. Is it right? So like 3-dimensional structures, and it will be the pi pyramidal structures. It is having the directly 109 degrees 28 minutes, 109 degrees 28 minutes bond angle, sp3 hybridization. Like that each and every bond will be separated like that, bond angles with the bond angles and the hybridization. Based on these only, carbon is having the very main role participating. So this is the hybridization, one of the important. First one is the versatile nature of the carbon, second one is the carbon involving into the hybridizations, and third one is the how to forming the structures of the carbons differently amorphous and crystalline forms of the carbons, amorphous and crystalline forms of the carbon. See that. So carbon atomic number 6, carbon atomic number is 6, so atomic mass is 12, and here see that, so that is the crystalline form and amorphous form, So crystalline forms we have to seeing the 2 types of forms we have to dividing the carbon, that is the crystalline form is diamond and graphite and Buckminster fullerenes. CNTS is the carbon's nanotubes, So in the fullerenes only it will be forming as in carbon nanotubes. Like that we have to seeing, and here we have to seeing the coke, charcoal, is it right? Coke, charcoal and carbon black. Carbon black we have to seeing lamp fires, lamp. సో మనకి ఓల్డెన్ డేస్లో ల్యాంప్స్ ఉండేవి చిన్నవి, అంటే బుడ్డి అంటూ ఉంటారు వాళ్ళు. సో దానికి గ్లాస్ ఉంటుంది, కంటిన్యూగా ఫైర్ బర్న్ అవుతూ ఉంటే ఆ గ్లాస్ చుట్టూ కొంత బ్లాక్ యాష్ ఫామ్ అవుతుంటుంది, ద ల్యాంప్ బ్లాక్ అంటాం దాన్నే. సో ఆ బ్లాక్ యాష్లో కూడా కార్బన్ ఉంది. సో దట్ ఈజ్ అట్ ది సేమ్ టైం నవ్ డేస్ వీ హ్యావ్ టు సీయింగ్ క్యాండిల్ ఫ్లేమ్ మీద కూడా మనం కొంత ఏదైనా సరే స్పూన్ కానీ లేకపోతే ఏదైనా అక్కడ అడ్జస్ట్ చేస్తే ఫైర్ మీద ఆటోమేటిక్గా బ్లాక్ యాష్ ఫామ్ అవుతుంటుంది. దట్ ఈస్ ద కార్బన్. ఇట్స్ ఆల్సో రిలీజెస్ ది కార్బన్. ఎవ్రీ ఫైరింగ్ మెటీరియల్ ఇట్ విల్ బి రిలీజెస్ ది కార్బన్. సో totally carbon is there in the different forms. This is the versatile nature of the carbon. Individually we have to studying about these diamond, graphite and Buckminster fullerenes and nanotubes. So these are the nanotubes we have to seeing. It is also there in the Buckminster fullerenes. Is it right? So different structures by diamond and graphite and Buckminster fullerenes. See that diamond. So structure of the diamond we have to seeing it is the hexagonal structure. How to you say sir hexagonal structure? See that this is the hexagonal structure. That means everywhere 6 carbons is there attaching around this It's a closed structure. See, like that carbons are arranged here. Is it right? So it is also be having as a bond angle in between the carbon to carbon is 109 degrees 28 minutes. 109 degrees 28 minutes, and is one of the hardest insulator in the universe. So one of the hardest insulator in the universe, but we already discussed carbon is the best conductor, but why diamond is the one hardest insulator? Because of it is the highly burned and forming a new turning of the carbon compound, that's why it is completely turns into the glass transparent material, directly transparent material, and at the same time it is having the very highly polished structures, and it will be directly having the contrast bond angles of the low weight bond angles. So like that it will be forming as an diamond structures, diamond structure. Is it right? Next one, structure of the graphite. So here see the structure of the graphite. We have to seeing the, it is a very thin layers of the graphite. It is also be an hexagonal structure, we have to seeing, but it is only every carbon is attached to the 3 carbons directly. Is it right? So like this, and here also every carbon is attached to the 3 carbons directly. We have to seeing that 3 carbons it is forming as a thin layers. How do we telling these thin layers? We are using the lead pencil. Is it right? So that lead pencil easily it will be decreases by writing. Length is decreasing. That's because only that lead pencil is the graphite layer structure, and it will be forming the each carbon atom is graphite is joined with the only 3 other carbon atoms, and at the same time flat layers of the carbon atoms, these are indicating the very thin layers, and it is a weak forces of the van der Waals attractions, and hold layers of the carbons. These strong bonds existing between the carbon and carbon layer. So carbon to carbon. Is it right? These are the strong bonds which existing in between the carbon to carbon, and this is the very weakest layers we have to seeing these bonds, very weakest. That's why these are carbon easily it will be disappearing the layer to layer. Is it right? So that we have to seeing these carbon graphite structures. Graphite is a very useful material in our daily life. We have to using the many situation. By folding of these graphites, it will be forming as an Buckminster fullerene and nanotube. That nanotube and Buckminster fullerene we have to see that Buckminster fullerene. It is in the shape of soccer ball. That is the football. Is it right? So how like it is also be an hexagonal structure. Like this. So everywhere it is the carbon atom is there, like this is attaching. Is it right? So like that we have to seeing these are attaching of the carbon atoms. Is it right? So here we have to seeing these all attachments, So it is directly the central atom is surrounded by the hexagonal structure like this. See in the graphite, like that. At the same time Buckminster fullerene also attached to the like these structures. Everywhere 3 carbon atoms is surrounded, like this 3 carbon atoms, main atoms is surrounded by the main carbon, and differently they will be attached to the Buckminster fullerene. It is calling as an C60. It is having the 60 carbon atoms. A central atom is surrounded by the 60 carbon atoms, and it is a closed structure like as an soccer ball. What is the advantage for? So these fullerenes are introduced by the Buckminster fullerene is introduced by a group of scientists. They have to introduce it, and they have to giving the name to this Buckminster fullerene. Is it right? So what is the applications of the fullerenes? So how to using in what are the usages, and how where we have to observing these Buckminster fullerenes in daily life. That is the as per photo resistance in the photographic processes. Photo resistance in the photographic processes. That means simply light reflectors. Light reflectors we have to using, and the it is the preparation in the preparation of superconductors. Preparation of superconductors. Why? Because it is the 200 times more conductivity compared to the copper. Compared to the copper. So కాపర్ కంటే 200 టైమ్స్ మోర్ కండక్టివిటీ ఉంది వీటికి. సో గ్రాఫైట్ కానీ బక్మినిస్టర్ ఫులరిన్ కానీ. దట్స్ వై ఇట్ ఈస్ యూజ్డ్ ఫర్ ది ప్రిపరేషన్ ఆఫ్ సూపర్ కండక్టర్స్ ఇన్ ది ఎలక్ట్రానిక్. సో ఎలక్ట్రానిక్స్ అండ్ మైక్రో ఎలక్ట్రానిక్ డివైజెస్. Electronics and microelectronics devices like breadboard preparation devices it will be using. In optical devices also. Optical devices. So it is used in the optical devices also by the collecting the information from the certain distances where the persons are not going, like that human body, inside human body, that some of the things and organs we have to identifying and taking the pictures. These are all we have to using the optical devices also. And batteries as the charge coins. Is it right? So batteries and charge coins. So preparation of the soft ferromagnet with the zero eminence. So ferromagnetic substances, these are preparation of the soft ferromagnetic substances. These are the applications of fullerenes. Applications of fullerenes. And next one, see that nanotubes. Nanotubes. So nanotubes is the graphite layer structures. This is the graphite layer structures we have to seeing. By folding of these layers, like this folding of these layers, it will be forming a tube like structure. Tube like structure. So these tube like structure we have to taking as an nanotube. Nanotube is the thin layer. It is the folder of the graphite layers. Graphite layers. Graphite layers that will be forming a tube like structure. Tube like structure that is calling as a nanotubes, and it is also very usefully in our daily life. Many situations we have to using. That is see. So applications of the nanotubes where we have to using, it is the mechanical properties. What are the mechanical properties? Strong composites and bio scaffolds and hard coatings, fibers, preparation of the fibers, and these are all the. So next optical properties also here we have to seeing sensors, biomedical applications, tags, like that thin film transferations. So these are all we have to using for the applications of the these using the mainly 4 sectors. Surface area, like that how much it will be using, and electrical properties, optical properties, mechanical properties of the nanotubes. So very important, and these are used for the nanotubes. Is it right? So nanotubes usages, these are all. So what we have to knowing today, these are all only the what is the carbon, how to forming the carbon valencies, and what is the bonds forming carbon, and next how what is the importance of the carbon. In that one, 2 importance we have to see. First one is the carbon can involving into the 3 types of hybridizations, and next one, carbon can available in the different types of versatile nature carbon. So different forms, that is the crystalline and amorphous. Crystalline 3 properties we have to seeing, that is the graphite and diamond Buckminster fullerene. This is a Buckminster fullerene layers, like as a graphite layers folding also we have to getting the these nanotubes. Totally these are the totally applications and usages of these nanotubes Buckminster fullerene. Here what the questions they will ask, what is the conductivity compared to the copper, the nanotube Buckminster fullerene conductivity or nanotube conductivity, graphite conductivity. So compared to the copper, directly it will be taken as an 200 times more, 200 times of more conductivity. And what is the structure of the these graphite layers. How to forming the nanotubes? By folding of graphite layers. Applications of fullerenes and applications of nanotubes, where these are using medical properties and optical properties and the surface area. That the next electrical properties of these nanotubes. Is it right? So formations totally, and these are the about these carbon and its compounds. Preliminary information in this one we have to seeing the carbon importance, versatile nature, different hybridizations. Next class we will see the different properties, like how the carbon is importance, and next properties what are that we have to discussing. Is it right? So that is